In this video, we're going to be exploring angles formed by transversals. But before we get too far into that kind of discussion, let's talk about some angle basics. In order to discuss the angle basics, okay, you'll need to add this into your notes on either separate paper or on the bottom of page 2. This is certainly your choice. Just a word of mention that these notes must be included for credit, right? These additional notes must be in your assignment for me to consider the assignment for credit whatsoever. Okay, so now after that public announcement, let's move on. First and foremost, the smallest of basic angles, the acute angle. It's small and cute, like a baby. That's why we call it an acute angle. An acute angle has a measure that's strictly less than 90 degrees and strictly greater than 0 degrees. It can't be 0, it can't be 90. It has to be somewhere in between 0 and 9 degrees. So an example of a measure would be something like 37 degrees, 15 degrees, right? Those are measures that are somewhere between 0 and 90. This one up here, for example, I don't know, well, if a 90-degree angle is roughly like this, then maybe 20-ish might be a good reference, 15-ish. Okay, we want to be able to look at angles and kind of ballpark, right? We want to be able to ballpark an angle measure just by looking at it. Next. The next one, sort of the polar opposite of a little guy, would be a big guy, an obtuse angle. An obtuse angle is going to be greater than, strictly greater than 90 degrees, so bigger than that right angle, and smaller than 180 degrees, a straight angle or a straight line. So again, looking here, it's a pretty big angle. If this was 90 degrees, and this is 180, and it looks like this is about an additional 90 plus another 45, so altogether perhaps about 135 degrees, right? Again, ballparking, so 135 degrees would be a number that's somewhere between that. Just another pie in the sky number, 157 degrees, would be an example of an obtuse angle. Okay, the last two are very straightforward. Right here, we have our right angle, and we're familiar with that, working with the Pythagorean theorem. A right angle, x is exactly, no more, no less, 90 degrees. That's it. And for straight angles, we have right here, it's a straight line. That would be x is equal to 180 degrees, no more and no less. So it's either super small, acute, super big, obtuse, exactly 90, right angle, or a straight angle. Those are our four basic flavors of single angles. So when we're talking about one angle at a time, that's how we describe them. This video is going to be all about angle pairs. Okay, so again, just like our previous video, we're talking about two at a time. All right, let's keep exploring. Now, specifically, we're going to keep seeing this word transversal. So what is a transversal? Well, first, we're going to label the transversal lowercase t. And the other lines, we're just going to call them lowercase l and m. All right, so just two random lines, l and m, and t is our transversal. What makes a transversal a transversal? So what exactly is a transversal? A transversal, get this into your notes, is a line that intersects two or more lines. So T is our transversal. Why? Because T intersects line L here and line M here. So it certainly intersects exactly two lines. Now what does it create? It creates a whole bunch of stuff. Up here we have angles 1, 2, 3, 4. We know from the previous video that angles 1 and 3 are vertical. Also, angle 2 and angle 4 are vertical, right? Which makes both of them congruent. Then there's some linear pair things going on, right? Angle 1 and angle 2 are a linear pair. So are angle 3 and angle 4, right? They're a linear pair, and so on and so forth. And the same relationship is going down at the bottom. What our conversation is going to do today is link someone from the green group to someone from the blue group. All right? And we're going to learn All kinds of new stuff today, so hang in there. Now, on a side note, I want to think about two people, and these people are little red people, and they're twins. I guess you know where I am now. Now, I want to give each of the twins their right hand or left hand, depending on where they're facing. Both of these hands are on the same sides of their bodies, right? So we would refer to those as corresponding parts of their bodies, right? They're both I'll call them the left hand. They're facing away from us. Those are both their left hands. And then perhaps we have both of their right feet are also corresponding body parts. They're on the same side of each body. Now, that should help us explain what corresponding angles are. Those are angles that are on the same side of the transversal and in the same position with respect to the lines they occupy. Let's take angle 8, for example. Angle 8 is to the left of the transversal, and angle 8 is below line M. Who's to the left of the transversal and below line L? So you say, well, that's pretty simple. That's going to be 4. 4 is to the left of the transversal and below the line L. So that would make angle 4 and 8. Angle 4 and angle 8 are corresponding angles. Let's see who else is. So what we want to do is think about this idea of, right, left or right of the transversal and above or below their occupied lines. So here's our transversal, line M, line L. So 4 and 8 were to the left and down. Who's to the left and above? 1 and 5. So angle 1 and angle 5 are also corresponding angles. Those were both the sets to the left. How about to the right? To the right and above, we have 2 is to the right of the transversal and above L. 6 is to the right of the transversal and above M. So angle 2 and angle 6. And then lastly, the last group standing, 3 and 7, angle 3 and angle 7. And not just because they're the last ones, but 3 is to the right, 7 is to the right, 3 is below L, 7 is below M, corresponding. And there you have the 4 pairs of corresponding angles. Corresponding are the only pairs of angles that have 4. The rest only have 2. Let's move on. Okay, so we have the same picture, and we're moving on to alternate interior angles. So they're interior angles. They're not next to each other. They're non-adjacent, and they're on opposite sides of the transversal. That's what we mean by alternating. So first, let's talk about inside. I would say inside is all of the angles on the inside, right? 1 and 2 are on the outside, and 8 and 7 are on the outside. But 4, 5, 3, and 6 all seem to be squished between the L and the M line sandwich. So now coming back to the definition, they're going to be on opposite sides of the transversal. So 4 and 3 are on opposite sides, but they are adjacent. We want non-adjacent. So who are non-adjacent on opposite sides? Angle 4 is on one side, angle 6 is on the other. They're alternating across the transversal. They are non-adjacent, they're not neighbors. So 4 and 6 are alternating interior. Likewise, 5 and 3 are opposite and non-adjacent, so angle 5 and 3, right? So we have 2 pairs of alternate interior angles. Moving on. Keeping in the spirit of alternating, now we have alternate exterior. So again, if this is the interior, then the exterior would be 1 and 2 and 8 and 7, right? This is my idea of what exterior angles look like. Now again, they're going to be non-adjacent and on opposite sides of the transversal. So 1, who else is outside and on the other side of the transversal? 1 is on the left of the transversal, 7 is on the left, and 7 is on the right, one is on the left, and they're non-adjacent. So angle 1 and angle 7 are alternating exterior, right? Opposite sides of the transversal and not neighbors. And who else? 8 and 2. So angle 8 and angle 2 are also alternating exterior angles. Okay, and again, two pairs of those. And let's wrap it up. Our last group is going to be consecutive interior. And again, the interior is here. Consecutive means sort of one right after another. So they're interior angles that are on the same side of the transversal. Well, this is a no-brainer. 4 and 5 are interior angles that are on the same side as the transversal. And 3 and 6, angles 3 and angle 6, are on the same side of the transversal on the inside. Another name is same side interior, right? Same side interior is also an alternate name for consecutive interior angles. All right, now let's see what we can do with this. We'll have some examples, right? As you move down in your notes, we're in the examples part, right? And what do they want us to do? They want us to name the type of angle relationship, and if no relationship, write none. So let's just start with a couple of randoms. Some I might name that they're looking for, and some not so much. How about 2 and 7? So let's take a look at our options. We have corresponding angles, right? They're going to be on the same side of the transversal, same position. We have consecutive interior. They're also on the same side of the transversal, but only on the inside. Then we have alternating interior and exterior, right? Non-adjacent and opposite sides of the transversal, and just depending on whether or not they're inside or outside. So we look at 2 and 7. They're on alternating sides of the transversal, and they're not adjacent, and they're on the inside. So 2 and 7 would be alternate interior. How about 2 and 3? They're on the same side of the transversal, right? So are corresponding, and so are consecutive interior. These are both same side, but these are on the same side on the inside, so these guys would be consecutive interior. 2 and 3, consecutive interior. How about, say, 1 and 8? Alternating sides of the transversal, but these guys are on the outside, so I think they're alternate exterior. They're non-adjacent, right? They're not neighbors, and they're on opposite sides of the transversal on the outside, so alternate exterior. Who else are alternate exterior? 5 and 4, also alternate exterior. Okay. How about 1 and 7? They're on alternating sides of the transversal. They're not both interior. They're not both exterior. 1 and 7 are simply a none relationship. There is no word that describes their angle relationship. All right, one we haven't talked about yet. How about 5 and 7? They're both below the transversal R, and they're both to the left of their respective lines that they're next to. So since they're both on the same side of the transversal and in the same relative position, they are corresponding. All right. So just to run through one last time, if we just want a pair of corresponding, we would have, say, 2 and 4. They're corresponding. If we wanted alternate interior, then 6 and 3 would be a good example of alternate interior. If we wanted alternate exterior, 5 and 4 would be a good example of alternate exterior. And if we wanted consecutive interior, 6 and 7 would be a good example of consecutive interior. Now moving along to sort of an upgraded level of the questions, at this point you might want to press pause. And complete the notes section up until this point, right? To get your grounding in the topics. The next section should not be attempted, right? Do not attempt this section until you practice the easier part first, right? So press pause and complete the notes section up through now. Okay, so you should either be done with the notes section right now, or right now you're flying without a net. All right, so the most important part here is this idea that angles must belong to the same transversal to be an angle pair. So I'm just kind of choosing E, F, and G and H as examples. So I look at 4 and 7, and 4 and 7 are here. Now, who would be the transversal? What I want to do is I want to just focus my attention on this section. In order to drive that point home, it'd be like holding an index card, and you can help yourself to an index card. So I'm going to cover up the bottom section here because I don't really need to see it. And now this gets easier. 4 and 7 are obviously both on the inside, on the same side. They are consecutive interior. And CONS period, INT period, is a reasonable abbreviation. All right, and that's the trick. So I'm going to move the rectangle away, erase my work, and then head on to 2 and 10. Okay, so first I'm going to go find angles 2 and 10. So 2's here, 10 is here. And so what I want to do is I want to move my rectangle as such and adjust it so that I, again, just see what I need to see. And so now we're talking about line A as the new transversal. And what do I notice? 2 is to the left of the transversal, 10 is to the left, 10's above its respective line, 2's above its respective line. So sounds like, feels like, corresponding. All right, let's erase and readjust our rectangle. Next on the board, we have angles 8 and 14. So I circle here. They're both on the inside and on the same side. So 8 and 14 is another pair of consecutive interior. And the last ones we have here are 6 and 11. All right, I had to press pause and do a little behind the scenes action. Now let's see, I got 6 is way up here and 11's down here. This is the transversal for 6 or this one. Neither one of those is the transversal for 11, so I think there's just really no relation for 6 and 11. And that's the trick. The trick is to use an index card and kind of move that around as you see fit to help you answer these questions. Good luck in this section. Finish it on your own. As we approach the sort of back end of our portfolio here, it's a name that transversal. Okay, so let's just take one for example. 1 and 12. I look at here and here. So who would be my transversal? I think that would be line L. For 12 and 14, I look and I see 12 is here and 14 is here. So they're both along transversal right here. That would be line K. All right. And across the bottom, what I'd like for you to do across the bottom is to name all of the corresponding angles, name all of the alternate interior, all the alternate exterior, and the consecutive interior for the following transversal. All right. Using transversal K. All right. Using transversal K. So that's right here. So this is going to be our group of angles. And so perhaps you just want to cover up that top section. You should have 4 pairs of corresponding, 2 pairs of alternate interior, 2 pairs of alternate exterior, and 2 pairs of consecutive interior. You may want to divert back to the front page of your notes to complete this. Moving along. Press pause. Fix this up, and then get going. The last section asks you to name that angle pair. So given the diagram below, this diagram, I would like you to determine whether the angle pairs are corresponding, alternate interior and alternate exterior, so on and so forth, or no relationship. Then I'm just saying there's no need to color the boxes unless you want to go grab some colored pencils, and feel free to do that with the instructions that I sort of cropped out over here. All I really want you to do is just name/identify them. So in the second row, you'll notice you have angles 3 and 5. So I see angles 3 and 5. So I'm focused on this transversal right here. They're going to be consecutive interior. 14 and 16. Take a look. Here's 14, here's 16. They're both below the transversal and to the right of their respective lines. Those are corresponding. Okay, I'm just going to abbreviate that as correspond. 1 and 3. All right, let's take a moment to erase a little bit here. 1 and 3 are right here. They're both above the transversal that they're next to and to the left. So I guess 1 and 3 are also corresponding. Okay, and then 5 and 10. 5 is up here, 10 is right here. So I guess I'm focused on this transversal right here. 10 is on the outside on the left. 5 is on the top on the right here. So 10's on the bottom left, 5's on the top right. They're both exterior. They're on opposite sides of the transversal, non-adjacent, looks like, feels like, alternate exterior. All right, go ahead and finish up that page. So at this point, ladies and gentlemen, you should have enough information to complete the entire packet, right? The entire packet. But there's no arithmetic in here. It's just all pure vocabulary. But it is important vocabulary. These angle pairs, right? And by these angle pairs, I refer to corresponding alternate exterior and alternate interior, along with consecutive interior. All right, so these 4 pairs plus vertical angles and linear pairs, so another 2 pair, right? So 6 pairs of angles altogether, corresponding alternate exterior, alternate interior, consecutive interior, vertical angles, linear pairs. These angles are going to be with us all year long. So please, please, please do take the time to learn these relationships. Whoops, this is a misspell. It will pay off for months to come. I promise you this is worth it. All right, thanks for playing along with me, and we'll see you next time. And just so we have this spelled correctly, relationships. All right, take care.